Alrighty, welcome back. So now let's continue with our study of tech frequencies. So our last lesson, which was the first part of tech frequencies, it was sort of introductory. You'll notice we didn't actually talk much about the tech frequencies. We talked just generally about radio waves. And we needed this discussion actually though, because we needed that in order to be able to even talk about tech frequencies. And today's lesson is still going to be a little introductory because we still need to know some more stuff before we learn about the actual tech frequencies. But we will get a little more into the nitty-gritty of what frequencies you're allowed to use as a technician operator and other details related to that. So the first thing we're going to look at today, you need to know that ham radio frequencies are categorized. So when I say that they're categorized, what exactly do I mean by that? Well, let me show you, let me explain to you. So there are three basic categorizations that you need to know: the HF, VHF, and UHF. So basically, HF stands for high frequencies, and the high frequencies category consists of all frequencies from 3 to 30 megahertz. And you'll remember the megahertz, these are frequencies. VHF stands for very high frequencies. That category of frequencies is 30 to 300 megahertz. And finally, UHF, that's ultra high frequencies, which is even above very high frequencies. That's 300 to 3000 megahertz. Now, you can easily remember these because they're all multiples of 3 to the 10th power, to certain powers of 10. So you can easily remember these categorizations, and you should write these down in your notebook and try to memorize them because there will be questions on these during your ham radio test. Now, another thing you need to know as we move on away from the categorizations is that hams often refer to frequencies or frequencies on ham radio as bands. So what is a band on ham radio? So a band is just a group of frequencies that are all close together. And each band is labeled by its approximate wavelength. And you'll remember we talked about wavelengths. It's the length of the wave. So what do I mean by that? Well, so there's the 20 meter band, and the 20 meter band consists of a group of frequencies all next to each other, and their wavelengths are approximately 20 meters long. That's why it's the 20 meter band. The 2 meter band is similar, a group of frequencies all together with wavelengths approximately 2 meters. There's also the 6 meter band with wavelength of 6 meters, etc., etc., etc. Now, speaking of the 6 meter band, it turns out that this 6 meter band is a bit weird, or at least the questions that you might get asked on the test about it are a little weird. So let's look at one of these sample questions, and it asks, which frequency is within the 6 meter band? And it gives you a list of choices, which you can see here on the screen: 49 megahertz, 52.525 megahertz, 28.5 megahertz, 222.15 megahertz. Which of those is within the 6 meter band? So do you remember yesterday we learned about the formula for this? I left it up here on the board. Frequency equals 300 divided by wavelength. And both of these equations are going to come in very useful. And we can actually try to use this equation to solve the answer for this problem. So we know that this is the 6 meter band. The 6 meter band, the number 6 stands for the wavelength. So the wavelength is 6. So let's just plug the wavelength into this formula to get the frequency. So 300 divided by 6 is 50. And 50 isn't exactly one of the answer choices. And you might think something's wrong. Well, this formula, turns out, it just gives you the approximate frequency, or this one gives you the approximate wavelength. It's not always going to be exact, but it'll usually be close enough. So in general, what you do when you get a number out of these equations, you just pick the answer choice that's closest to that number. Just pick the nearest choice, the closest choice. And in this case, that would be choice A, right? Because 49 megahertz is close to 50 megahertz. Actually, for some strange reason, this is wrong, and the answer is actually choice B, 52.525 megahertz, which is the second closest choice, even though the closest choice is 49 megahertz. So that's why I say that this question is weird. The equation, this is the only time on the test where this equation is going to get you the wrong answer. So for this question, you just sort of have to memorize the answer. You just have to remember that 6 meter band is in the 50 megahertz and above range. Specifically, 50 to 54 megahertz is the 6 meter band. And again, this is the only question on the test where the formula is going to give you the wrong answer. Other times you can use these formulas just fine and they'll get you to the right answer normally. But so for any other band, it's just normal. Just use the formula 300 divided by frequency equals band or wavelength. And that one formula, both of these formulas will actually cover you for a multitude of questions you can run into on the test. And again, of course, you can also convert frequency into band with band equals 300 divided by frequency, etc. So you'll be using these formulas a lot. And again, they give approximations. So if your answer is a little off, just pick the closest answer, except for the 6 meter question that we talked about. So, okay, now we've learned what ham radio bands are. And now that we know that, we can learn about something called ham radio subbands, or specifically what the test calls mode-restricted subbands. What in the world are those? Well, a subband, if you look at the word, you might guess this, but a subband is just a part of a band. basically. And a mode-restricted subband is a subband or part of a band that only lets you operate on certain modes. Okay, so what is a mode in ham radio? Well, let me explain. There are actually several different ways of talking to people through ham radio. So obviously there's the way of actually using your voice with a microphone, which is probably what you imagine when you think of ham radio. But it turns out you can also communicate to people on ham radio using other methods, like Morse code. And you may or may not know what Morse code is. We'll talk about that in a minute. And sometimes you can even actually plug a keyboard into your ham radio and send text through the keyboard. So these are different modes. We have different modes of talking to other hams. It's not just using our voice. That's what we mean by different modes. So going back to the topic at hand, which is mode-restricted subbands, a mode-restricted subband just means a part of the band where you can only operate on certain modes. That's all it means. Okay, so now we know that these mode-restricted subbands are subbands that restrict which modes you can use. But what exactly are the restrictions? Like, what modes can you use on these mode-restricted subbands? What modes are you not allowed to use? And usually, the test expects you to know that usually these mode-restricted subbands restrict you from using any mode except a mode like Morse code. And again, you've probably heard of Morse code, but if not, Morse code is basically just a code that we use to transmit letters and thus words. So the code turns each letter into a series of long and short beeps. For example, the letter A is comprised of a short beep followed by a long beep, and that sequence is the letter A in Morse code. And depending on the unique combination of long and short beeps, someone listening to Morse code can make out individual letters and string the letters together and thus make individual words and sentences. Now, the reason that mode-restricted subbands only allow Morse code on them is because Morse code, it doesn't take up a lot of space on the bands. So it has what we call a narrow bandwidth, meaning the width of it signal on the band is small, it's narrow. So other modes like voice take up a lot of bandwidth. So if you think about it, if you transmit the exact sound of your voice, there's actually a lot of information and data that needs to be conveyed over the airwaves in order to accurately transmit that audio and that sound. So, in fact, if you transmit a voice signal on, say, 14.225 megahertz, your signal actually isn't going to just stay and only be on 14.225 megahertz. Because there's so much information to convey, it's actually going to take up more space because it needs that extra space to convey more information. So your voice signal might actually occupy all the frequencies from 14.225 to 14.228 megahertz because it needs all that space to get the information through. So that's what we mean when we talk about bandwidth. Some of these signals, they're pretty wide because they need to convey all sorts of information. So voice usually takes up a lot of bandwidth. But think about Morse code. Morse code is basically just a bunch of beeps. And transmitting beeps requires a lot less information and bandwidth and space on the radio than transmitting audio. So Morse code takes up less space. And because of this, and because sometimes space is valuable in ham radio because some bands actually don't have a lot of space, they don't have a lot of room for wide bandwidth signals. So a lot of times only modes like Morse code are allowed on these mode-restricted subbands. And that's another thing you might get asked about on the test. And another little note is that Morse code is commonly called CW. And CW stands for continuous wave. CW is the same thing as Morse code. And the reason it's called continuous wave is because the transmissions that make up the Morse code beeps, they're just raw continuous radio waves that go in the receiver, and the receiver turns them into beeps. They don't have any sort of modulation towards them. And we're going to look at modulation and what exactly that means. We're going to look at that later in this course. For now, you don't need to worry about it. Just all you really need to know is that CW and Morse code mean the same thing. That's all you need to know for now.